So welcome to this latest video on 162 Maths. In this video we'll be going over the AQA AS Maths past paper of May-June 2023, paper 2, section B, which is the statistics section. Now before we get started working through these questions, just a little reminder that I'll include a question breakdown in the description below so you can see which topic refers to which question that we go over, and if there are any aspects that you are struggling with on these particular questions that we go through, feel free to check out the 162 Maths contents page, which has access to all the lessons covering the AS Maths syllabus. So looking at the first question of section B, it says the mass of a bag of nuts produced by a company is known to have a mean of 40 grams and a standard deviation of 3. The company produces 5 different flavours of nuts. The bags of nuts are packed in large boxes. Given the information above, identify the continuous variable from the options below. We need to tick one box. So if you hear, all we're doing is looking at the data collected for these 4 things and deciding which of these is going to represent continuous data. Now in terms of underlining what continuous data is, now continuous data is basically any number within a given range, whereas discrete variable is basically can only be certain numbers within a given range. So for example, let's say shoe sizes generally come in certain numbers, can't come in like beyond half sizes, so it can't come in 0.32, whereas weight, height, things of measure are basically given as continuous data. So here the correct one, so flavours of bags of nuts, well that's going to be more qualitative data where it's actually names. You've got the standard deviation of mass, which is again going to be, we already know is 3, so that's not going to represent continuous data. The mass of the individual bags, now that one is going to be continuous data. And the number of bags, well again you can't have 0.3264 of a bag, so that's why the last one is not representative of a continuous variable. Moving on to question 13, it says the table below shows the frequencies for a set of data from a continuous variable x. A histogram is drawn to represent the data. Find the frequency density of the bar in the histogram representing the class where x is between 42 and 24 inclusive of 42, and we need to circle our answer. So for this, frequency density is calculated by doing the frequency divided by the class width, which for 24 to 42 is 36, and the class width is going to be 42 take away 24, which is 18. So here the frequency density is going to be 36 divided by 18, which is 2, so we just need to circle our first option. Moving on to question 14, it says the manager of a factory wants to introduce a bonus scheme. The factory has 65 employees who work in production and 28 employees who work in the office. The manager decides to collect the opinions of a sample of 90 of these 93 employees. Explain how the manager could collect a simple random sample of 20 employees. So for this, all we need to do is basically say, how do we use a random sample to collect 20 employees for 3 marks? So the first thing you need to state, and again these are all open to different interpretations, so the first thing you want to do is you want a number, or give a number, each employee (1 to 93). Now the next thing you then want to do is then select using a random number generator, and that can be either on a calculator, a computer, numbers out of a hat, or you could use a random table, which is more for the older mathematicians. And then what you then want to say is then what you want to do is select a number ignoring any repeats. So what you could also say is that when you're drawing a number, well again if you're picking out of a hat, you always want to make sure, the problem with picking out of a hat is how fair and bias free is it? Are the papers going to be the same size? Are they going to be folded the same? Are they going to be in, like say like a Champions League draw where they're all in balls inside and you've got to unscrew them? I'm probably digressing, but you just want to make sure. So probably in terms of picking out the hat, you probably need to go into detail as to how you'd therefore make that clear, whereas with a computer, a calculator, it's a lot easier, where if you do a computer or a calculator, you potentially could have repeats. So ignoring any repeats until 20 employees are selected. So something along those lines would be absolutely fine. Then for B, it then says the manager collected the simple random sample of 20 employees. The manager noticed that all 20 of the employees in the sample worked in production and therefore the sample was not representative. State a different method of sampling that would give a more representative sample. So basically, because you want a number from different groups, you can either say the sample that you want is either going to be stratified sample or a quota sample. Whereas for the quota sample, once you've selected the amount of production that you want, you then move on to another category. So it's a bit like pot A, pot B. Then moving on to question 15, talking about pots. It then says numbered balls are placed in bowls of A, B, C. In bowl A, there are 4 balls numbered 1, 2, 3 and 7. In bowl B, there are 8 balls numbered 0, 0, 2, 3, 5, 6, 8 and 9. And in bowl C, there are 9 balls labelled 1, 0, 1, 1, 2, 3, 3, 3, 6 and 7. This information is shown in the diagram below. And it says that a 3-digit number is generated using the following method. So a ball is selected at random from each bowl. The first digit of the number is the ball drawn from bowl A. Second digit is from bowl B. And the third digit is drawn from bowl C. And for question 8, it's asking us to find the probability that the number generated is even. In order for it to be even, so let me just use a colour pen. So in order for the 3-digit number to be even, the last ball must be even. So basically what you're wanting is to work out the probability that the third ball is even. Regardless of what the first 2 balls are, it doesn't really make a difference. It's all about the third one that makes the number odd or even. So for this, if we just highlight how many are even, so we've got 1, 2, and we should have another one, 0. There we go. And so here we've got 3 out of 9, which simplified gives me a third. Then for question B, it says find the probability that the number generated is 703 or 703, more commonly known as. So for this, what we're wanting is the first ball to be 7, the second ball to be 0, and the third ball to be a 3. So again, looking at this, how many 7s have we got in the first ball? Well, we've got 1 out of 4. And what you want to do is you want to work out the probability of each of these. And the probability that the second ball is a 0, well, there's 2 out of 8. And for the third ball to be a 3, there are 3 out of 9. And what we then want to do is multiply those 3 probabilities together, giving us a grand answer of 1 over 48. Then for question C, it says find the probability that number generated is divisible by 111. Now, again, in terms of numbers that are divisible by 111, it's going to be 111, 222, 333, 444, 555, 666, 777, 888 and 999. Now some of these are not available for us to do because we don't have the correct numbers in each of the respective bowls. So the only ones that are possible is 222 and 333. So we want the probability of 222 or the probability of 333. Now the probability of 222 is going to be a quarter multiplied by 1/8 multiplied by 1/9. And again, the numerators all represent the number of 2s in each of the bowls, and the denominator is the number of balls in each of the bowls respectively. Or means add, and then what we then want to do is work out the probability of getting a 3 in each of the bowls. So that's going to be a quarter multiplied by 1/8 multiplied by 3/9 rather. So then typing that all into our calculator, we get a final answer of 1 over 72. Moving on to question 16, it says the discrete random variable x has a probability distribution, and it says, and there's a table. It says the discrete random variable y has the probability distribution. We have our table, and it says it is claimed that the probability of where x is greater or equal to 3 is greater than the probability of y is less or equal to 4. Determine if the claim is correct. Fully justify your answer. Now, as you can see, we can see in our table of x that we've got our probabilities, and there's no problems because they're all numbers. However, for y, we can see we've got a p. Now, one of the key properties with a probability distribution is that all the probabilities must add up to 1. So here, what we need to do first is we need to find p. So we add 0.3 plus p plus 0.2 plus 0.1 plus p plus 3p plus 0.05, and that all equals 1. So then all we then need to do is to simplify all of this, in which we then get, and let's just quickly simplify all of this. So adding up the p's, we've got 5p, and then adding all the probabilities, I've got 0.3 plus 0.2, apologies if that looks like 6.2, plus 0.1 plus 0.005, and already made a mistake on the calculator, and we get an answer of 0.65 equals 1. So solving this, we get 5p equals 0.35, so p equals 0.07. So then what we then do is we then look at the claim. So the probability of x being greater than 3, so if I just put a line through this, so the probability that x is greater or equal to 3, or greater or equal to 3 is adding up all of these 4 numbers together, in which we get an answer of 0.6. And then with y being less or equal to 4, we add these numbers up. So 3, probability that y is less or equal to 4 is equal to 0.5 plus p. Now we know that p is 0.07, so this therefore is going to equal 0.5 plus 0.07, which equals 0.57. So then going back to the claim, so as 0.6 is greater than 0.57, the claim is correct. Then moving on to question 17, it says that an archer is training for the Olympics. Each of the archer's training sessions consist of 30 attempts to hit the centre of the target. The archer consistently hits the centre of the target with a 79% of their attempts. It can be assumed that the number of times the centre of the target is hit in any training session can be modelled by binomial distribution. And then for 17a, it's asking us to find that the mean of the number of times that the archer hits the centre of the target during the training session. Now, the fact that we know it's a binomial distribution, we need to set our parameters. So we know that we've got 30 attempts, so sample size is 30, and we know that a probability of success is 0.79. So this here is our parameter, which again, really important that you do state somewhere in these questions. Now, it's only worth 1 mark, so again, probably won't get a mark for it, but again, if it was worth more, that will definitely be worth 1 mark. Now for this, to find out the mean of a binomial distribution, we just multiply n times p. So this is just going to be 30 multiplied by 0.79, which gives me an answer of 23.7. It then says for b, find the probability that the archer hits the centre of the target exactly 22 times during a particular session. So for this, again, setting up the parameters of 30 and 0.79, what we're looking for is a probability that x equals 22. Now for this, you will probably need to use your calculator or the formula, but seeing as you should have your calculator that should handle this. So again, if you've got the Casio calculators, if you go to distribution, then go to binomial PD. So let me just write this down. So we want to go for this one, we want to go menu, distribution, and we want binomial PD because we want the exact values, and then we want a variable, and then we just enter the values of n equals 30, or sorry, x equals, n equals 30, x equals 22, and p equals 0.79. So if I enter those numbers in, press equals, I get an answer of 0.1238577,896, which again I'm just going to write down and just round off to 0.124, and that's to 3 significant figures. Then for C, then says find the probability that the archer hits the center of the target 18 times or less during a particular session. So again, setting up the parameters, what we want this time is the probability that x is less or equal to 18. So again, the difference here, we're going for menu, distribution, we're going for binomial CD this time, and variable, and what we're wanting this time is that x equals 18, we want n equals 30 and p equals 0.79. So if I just enter those numbers in, I get an answer of 0.130993799698, which rounded up gives me 0.014. And again, that's to 3 significant figures. Then for D, it then says find the probability the archer hits the target more than 26 times in the training session. So for this, what we need to do, again, setting the parameters, we've got B 30 and 0.79, that's not changed. And so what we want is a probability that x is greater than 26. So that's going to be the same as the probability that x is greater or equal to 27. Now remember that your calculator does cumulative values, so only numbers that are less. So that's going to be the probability of 1 minus the probability of what we don't want, which is numbers less or equal to 26. So then if I enter this into my calculator, which again using the same binomial CD, we've got n equals 30, x equals 26, and p equals 0.79. We end up with 1 minus 0.9015596, which leaves me an answer of 0.0984404, which rounded up gives me an answer of 0.0984, and that's to 3 significant figures. Then moving on to question 18, it says that it is believed that 25% of the customers at a bakery buy a loaf of bread. In an attempt to increase the proportion, the manager of the bakery provided free samples to the customers to taste. To decide whether providing free samples had been effective, a large random sample of customers leaving the bakery were asked whether they had purchased a loaf of bread. An hypothesis test at 5% significance level was carried out on the data collected. The test statistic calculator was found that in the critical region. And so for 18a, it's asking us to state the null and alternate hypothesis. So for this, our null hypothesis is going to be that p is equal to 0.25, so there's no change. And for H1, that the probability of someone purchasing a loaf of bread is greater. So it's going to be a one-tailed test. Then for B, it then says state in context the conclusion of the test. So for this, it's quite crazy that we're not actually asked to perform a hypothesis test. All we're asked to do is basically just do the certain sections of it. So for this, we just need to give the conclusion. So here I'd write something along the lines of that there is, and as it falls within the critical region, we're accepting H1. So we could say we accept HO, or H1, I should say the alternate hypothesis, because it's inside the critical region. So there is sufficient evidence, I would say, at 5% sig level. Again, really important that you write that, to suggest that the proportion of customers buying a loaf of bread has increased. There we go. Then for question 19, it says a comparison of the masses in kilograms of convertible cars was made using the large data set. So again, this is based on the large data set, so make sure that you are familiar with that. It then says the sample of 20 masses was chosen from both the 2002 data and the 2016 data. The masses of the 20 cars in each sample were used to create a box plot for each year. The box plots are labelled box plot A and box plot B as shown in the diagram. And the question is asking us to estimate the median of the masses of plot A. So for this, all we need to do is, looking at box plot A, is basically decide what is that number going to be at. So again, the correct answers they would accept is any answer between 1,650 to 1,675. But again, it's really important you don't give a range, you give an answer. So I would go for halfway. So I'll go for 1662.5 kilograms. But again, any number between those two numbers stated here, remembering to state your units, would be absolutely fine. Then moving on to B, it says that it is claimed that box plot B must be incorrectly drawn. Give a reason why this claim was made. And again, something along the lines of the fact that box plot implies that there is at least one car with zero mass, which is not possible. So remember that the box plot represents the masses of cars, and as you can see from B, that there is a car which is zero, which again can't have a car that has zero weight. It then says comment on the validity of the claim, and you can see from the large data set that there are cars with, or car masses, let's just get the grammar correct, so there are car masses of zero in the data set. So the claim is incorrect. Then for C, and the final one, it then says that it is claimed that box plot B must be from the 2002 data. Give a reason why this claim is correct. And again, something along the lines of that the 2002 data is the only one with zero masses of cars. So something along those lines will be absolutely fine. And there we go.